In this video, we are going to derive the derivative of the cosecant of x. Now, pretty much that means we're finding the derivative of the cosecant of x. Now, we know that the cosecant of x is equal to 1 over the sine of x. So that's just pretty much what we're going to write it as. So this is equal to the derivative of 1 over the sine of x. And another way that we could write this is we could just say it's the derivative of sine of x raised to the power of -1. So then how do we figure out what the derivative of this is? Well, notice how we're pretty much taking something and raising it to the power of -1. So we could use the power rule. And so the way that we would use the power rule for something like this is that it's just going to be -1 times the sine of x raised to the power of -2. And so that's pretty much what happens when we use the power rule, but we're not done yet because we did the power rule with respect to the sine of x, which means we have to use the chain rule. And so what we're going to do is we're going to have to multiply by the derivative of the sine of x, which means we're multiplying by cosine of x. And so that's pretty much what we get. And so the way that we can rewrite this is we could just say that this is the negative cosine of x all over the sine squared of x. And so another way that we could rewrite this, we could say that this is just the negative cosine of x. Actually, we're going to write it this way. We could say that this is just -1 over the sine of x times the cosine of x over the sine of x. So this is equivalent to that. And so as a result, the way that we can write this, all right, we're going to get -1 over the sine of x, which is just the cosecant of x, right? And cosine of x over the sine of x is just the cotangent of x. And so this right here is pretty much the answer to the derivative of the cosecant of x. So this right here is the derivative of the cosecant of x. And so yeah, this right here is pretty much it. And so this right here would be the derivative of the cosecant of x. That's it.